Well, they're not Doritos, but at least they're cheese flavored. You want a chip? How's it going, everybody? Welcome back to Make It and Break It. My name's Andrew. This is Joey the Adventure Dog. And today, we're testing out some of our 3D printed items. So, last time on our Doritos Locos, I think it was Doritos Locos, I'm not sure what it was, we designed a trolley fixture base plate, something, to try and get some of these things out of our way in the middle of here and stored right beside me here underneath our workbench, so that they're kind of out of the way until we need them. And they're done, mostly. So this is what we designed way back when in CAD. It is actually the second printing. This is the first one. There were some issues. I'll go over them with you here. But essentially, this is what we designed. It's in black PLA because that's what I had a bunch of at the time. Yeah, these are our, I've been calling them motor trolleys or engine trolleys. These are our 3D printed plates that are gonna run on some casters, which I have somewhere around me here, and go underneath this transmission and hopefully this motor, because we found out that when we did the math, these pieces of plastic that we 3D printed should theoretically hold up to the weight of a motor like this, or even maybe our, Hemi that's sitting outside there. Although we're gonna build something different for that. That was a different video. That's coming up soon. But I did want to go over these things briefly, show you, sorry Bub, what you get as a result of 3D printing, some of the issues that you can encounter, including why this one's only about half of a piece. And then we're gonna finish our assembly here and go test it out. I'm a little nervous about this. So, here we go. All right, so we're up on the bench here just to give you a little bit of a rundown. This is our fully completed one, base plate, whatever. There is one blemish that I wanted to point out, and that's right here. So this is at the very top. So this was printing like this, and right at this top transition where it comes from this area in here up into this flat spot, there is like one layer that is offset, and so it's in here, and I think I have some B-roll showing some of this. It is actually set in on this side, and then there's an extra layer on the outside on this side. You can actually hear it kind of snapping there. I'm not entirely certain what caused the offset, but I suspect that there's something about the way this corner and this whole part was built that was causing issues at these transition points because of the other piece, which is this one. You can see it's about half. In fact, this is where the pieces meet for this first horizontal cross piece here. It's about half of the previous one. In fact, this failure is about where that missing line is on the top piece. So if this failure would have happened up here, it would have happened right here. So that's why I suspect there's something with the way this all comes together that is causing issues when you print it. But otherwise, this thing actually printed pretty well. The reason it failed is because of the way this prints. When it prints like this, there's a bunch of support material. You can kind of see the fuzzy edges in here, hopefully. There's a bunch of support material that fills up this void here to hold this horizontal piece. Actually, when it was coming through over here, this whole support material broke off, which meant that it was starting to print in midair, and as soon as it tried to create this line, this constant piece over here, there'd just be droops and globs and everything. So I saw it before it got too bad, and I killed it, and this was actually able to save most of the prints. So I've actually got a print sitting on the Raise 3D right now that is going to essentially create an end cap that we're going to slip over, glue on, and bolt into place, and hopefully be able to salvage this piece as some sort of little moving trolley or something like that. But that's the results. Let's go get the rest of the pieces to finish our installation, and I'll walk you through those real quick. Alright, so sitting here is everything that I need for 2 of these carts, plus far too many fasteners, but I figure if you're going to buy something on the order of 30 some odd, 40 fasteners, you might as well buy just a full box, and then you have spare fasteners if you ever need them. So, these are the casters we're going to use. These are Harbor Freight Special 5/8 or 1 inch or whatever they are. They're rated for like 60 pounds a piece, and their holes are basically perfectly sized for a 1/4 inch fastener. So based on our thicknesses here, this is a box of 1/4 20 by 1 inch fasteners, basically designed to, we take our old piece here, go like this and like this, and get bolted down. Nothing too fancy, if I do say so myself. Alright, so these will get bolted in like this onto all 4 corners of our pieces, and that will essentially lock them in place. So we have these washers if we need them. In these first ones, especially when they're just bolting straight through, we don't really have a bunch of thread standing out, so we probably could have gone with a slightly longer fastener. What are these, 1 inch? 1.5 inch probably would not have been amiss, but as you can see, these threads are not ideal. But it will hold it in place for now. We don't really worry about it staying together because there's going to be 4 of them, and this basically just is supposed to hold it in place over top of the wheels. So let's go get this assembled on our fully printed one and test them out. Alright, here's the thing. It rolls around fine, and I'm not hearing any immediate cracking. If I put my weight on it, there is a decent amount of deflection, but we knew there was going to be deflection. So let's try and put a transmission on it. Easy peasy. Could probably do with a bit of a strap down, but here she is. So it actually worked. I'm not super surprised that it held the transmission, because this transmission only weighs about 100 pounds. I think 102 if you go look it up. And we know this is dry because it got shipped overseas. But I am kind of curious if our math works out for the engine block, because I was never really worried about the transmission being held in here, but I am kind of worried about the engine block. So we're gonna go get our, or try to go get our hoist and see if we can put the engine on here. Change plans. Couldn't get the engine hoist in here because, well, so instead we're going to test with a another item that is large and can move itself around. Me. Because that seems like the smart thing to do, is to test untested components with your body. So I weigh on a par, and by on a par I mean some unspecified amount more than this engine block. So the Renesys 13B MSP engine block is 112 kilograms or 247 pounds, whatever it is. I am a large dude who is more than that, so if I can't get a hoist in here, I might as well check with myself. So we're gonna load it like we would the engine. So I've got these two things that I cut off the pallet that's in the garage. And just put these over here in a way that kind of covers it as much as possible. Terrified. And it's bending in the middle, but she sure does work. This is ridiculous. Alright, I'm getting the hell off now. While I'm standing on this thing to prove that it's good, even though it terrifies me. See, no hands, right? This is mostly for stability since this is 4 swivel casters underneath me. I did want to talk a little bit about affordability and why this is a really cool project, but I wouldn't necessarily suggest this as a thing that you do that isn't a hobby or to prove a point. So, this thing that I'm standing on right now, the full-size piece, is about 2.5 kilograms of PLA. Now I printed it not full infill, so it's maybe not quite as stiff as it could be, but it's pretty close, and basically 2.5 kilograms of PLA. So the PLA I'm using is a Matter Hacker stuff, so it's that stuff that's sitting right over there. And I get it from Amazon. Check the links down below if you want to get some yourself, since I'm obviously proving it's good. I get it for 20 bucks a kilogram. So I'm standing on $50 worth of plastic right now. On top of that, you're looking at like $2 for fasteners and another $9, I think, for casters. I don't remember how much these casters cost. They're Harbor Freight specials, so $2 or $3 a caster. So 12 bucks a caster. It's called 15 bucks for all the other associated hardware, not counting a 3D printer that can print something this big. That means the all-in cost for this thing, 3D printed, is $65 of actual material cost plus 5.5 days of print time. If you're trying to prove a point, doing a project like this for YouTube, that makes sense. Here's the problem. Don't do this for yourself at home, because you can go to Harbor Freight, where I bought those casters, and get an 18 by 30 wood plank swivel caster moving thing that has a 1,000-pound capacity for $15. So I think this feels like a Top Gear episode because we've proven that if you spend more money and more time and engineering, you can build a product that's 4 times as expensive. So, I don't know what we proved, but this is really cool because I've been standing on this plastic thing, moving around in a way it's not really designed to hold, and it's holding me just fine. But it's terrifying. So I'm going to get off here. Thanks for watching, everyone. My name's oh. Knew that was going to happen. So, speaking of Top Gear endings, we spent 4 times the money on 1/4 of the capacity, and it broke at the very end, just when we thought we'd made it. So, looks like this thing's broken. It actually looks like it broke in a way that these end pieces that I'm making for this one would fit quite well on them, so I might end up with 4 tiny trolleys. Not that I'm gonna put this thing on it anymore, because yeah. So anyway, I think I was in the middle of ending this video. Thanks for watching, guys. If you like this video and the surprise twist ending, definitely hit a like. Comment down below. Are you surprised that it didn't actually hold me forever? I'm a little surprised, but also not that surprised. Let me know in the comments section down below. If you like what we're doing in this channel, We do motorsports builds, cars, race cars, motorcycles. We do some 3D printing and technology along with that. So if that sounds good, check the rest of our videos out and subscribe somewhere around here. And thanks for watching, everyone. Again, my name's Andrew. This is Make It and Break It. Normally spelled with like breaks, but sometimes spelled with breaks. Until next time, we'll catch you later.